As can be seen, here is the main circuit for the electronics. Right there is the power system on the right, and on the left you will have the main electronics, where there is the Arduino, which is controlled by the AI and its decisions. And here is also the ESP, right? This is a breadboard for the voltage divider, or the resistive voltage divider, where the temperature sensor dipped inside of the gearbox will actually send data back to the Arduino, and the Arduino will send it to the ESP, which will then send it to the laptop. And here is the main electronics communication board. You can see here is the main breadboard where there is all the communication that is happening, okay? And inside of there is also the relay module, which is normally open. It will close to feed power to the pump, which will then take oil from the reservoir and then feed that oil into the gearbox. Power is connected. You can see that the Arduino, the ESP, as well as the relay module are fully operational. Explain that the oil extraction is done once the oil is injected in 0.15 liters. You will have to also extract about 3 or 4 minutes later the oil manually. There are other options to do it, but the easiest and the least cost-effective way is to use the grooves lining the inside of the gearbox and ultimately use the manual extraction. It takes 15 seconds to do that. Box, as you can see here, there are these grooves, and each one of those actually represents 0.15 liters of oil. And in general, therefore, this is the line that you have to follow. This is something that I figured out by calibrating it myself and adding specific quantities of oil that I knew, and then repeatedly trying back to back to back until I was confident it was 0.15, 0.16 liters. Now, as can be seen here, this is going to be the AC driver, or the VFD, the variable frequency converter, that will drive the AC motor, which will then drive the gearbox. So here is an AC filter, and these things you see here are basically ferrite cores. So those are ferrite cores and the AC driver together, the AC EMI filter together. They basically ensure that there is no electromagnetic interference from the variable frequency converter. This is the entire pipeline. Can be seen after starting up the whole system. You can see that the temperature has just started. The VFD, the variable frequency converter, has to be kept away from all the other electronics because it is a source of electromagnetic interference. You see, after 5 minutes, the temperature is climbing more rapidly, and it will eventually reach the 50, 55, and 60 terminal points. You can see the temperature has climbed higher. Here you can see the absolute error, life of the absolute error. And so as the two timelines catch up, you'll see that the error graph is going to update, and the error is mostly around 1.5 Celsius degrees. Temperature of the system is approaching 55 right now, as you can see. And the AI is the blue line, and it is ahead of the real temperature value. As can be seen, the relay turned on and the gearbox was lubricated. Here that after the lubrication, the temperature dropped substantially, which was because of an AMI pulse. But after that, the system recovered, and you can see that the overall rate of climb, or the slope of the temperature, the rate at which it goes up, reduces substantially. You can see that once again the gearbox has been lubricated for a second time. Effectively, the slope of the temperature and the rate at which that is going up reduces substantially after each lubrication, and therefore the system is made more and more and more stable. Important to analyze, after the 60 lubrication, the rate of the temperature climb has become more or less constant, okay? Essentially, if you look here, from 2500 all the way to 3500, the temperature is within 54 to 55 Celsius degrees, okay? However, which is 1000 seconds. However, from 2000 to 2500 or 1500 to 2500, you can see that the temperature had gone up almost 10 Celsius degrees, meaning that the overall rate at which the temperature increases has reduced significantly. That this is more true now, and therefore the overall capacity for the AI model to function as a controller is actually achieved. In other words, the objective to develop, to validate, and to investigate, the investigation reveals that the AI model can operate as a controller for a subsystem in a gearbox. Evident here, there are some electromagnetic pulses or interferences that can be seen in the results of the AI model. However, regardless, that does not affect the overall trend of the system. The system continues to march upward, in a stable way, or downward in a stable way. However, every now and then there are these spikes, and they do happen, and it's because of the electromagnetic interference from the AC driver, the variable frequency converter. Seen right here, this demonstration lasted for 1 hour and 5 minutes, 1 hour 6 minutes.